Assalamu alaikum viewers, welcome to my channel. Today we are going to learn about Physics 11 lecture 2, that is about chapter 1 measurement. So let's start with it. In lecture 2 we will discuss about the quantities, the physical quantities, that includes the base quantities and the derived quantities. After that we will discuss scientific notation, their rules for our convention for indicating the scientific notations, errors and uncertainties. Firstly, we have to learn about what are the physical quantity actually. A physical quantity is a property of a material or a system that can be quantified by measurement. A physical quantity can be expressed as a combination of a numeric value and a unit. We can take example of any mass, okay, like the physical quantity mass can be quantified as n kg, where n is the numeric value and kg is the unit. And laws of physics are expressed in terms of the physical quantities. Here we can take example of the physical quantity. That what is a physical quantity actually is, we have learned about that one must be n and kg, where we can say that n is the numeric value and kg is unit. Like the kilogram is actually a unit. We can also take example in a numeric value like the 10 kg. We can see that we have a packet of sugar that is of mass 10 kg. So we can calculate its the physical quantity. This is the physical quantity that can be expressed in terms of their unit and their numeric value. So this is actually the example of the physical quantities where the laws of motions can be expressed in terms of physical quantities. Laws of physics can be expressed in terms of physical quantities. We have the different examples in our daily life that includes maybe the size or the mass of anything, any material, any tool, anything, okay. And while we are taking example, we should have learned about it that one must be a numeric value and the second one is a unit, okay. When they combine together they will become a physical quantity. Now we can see that what are the fundamental physical quantities. Actually the most fundamental physical quantities are 7. That may be the length, mass, time, velocity, density, force and electric current, temperature. And when the amount of the substance and the luminous intensity is also involved and also termed as the physical quantities, but the most particular and the 7 fundamental physical quantities are length, mass, time, velocity, force, electric current and density. Now we have to learn about what are the different types of physical quantities. There are the two different types of physical quantities. One is the based quantities and the second one is the derived quantities. And we have to clear our mind according to the base quantities and the physical quantities, the different type, that is the derived quantities. The base quantities actually are the fundamental physical quantities that are not defined in terms of other physical quantities. Like we can take the example of length, mass, time. And in case of the derived quantities, these are the quantities whose definitions are based on their physical quantities, means their definition like velocity is based on two different units, ms minus 2 in case of acceleration, ms minus 2 means meter per second square. Then we can say that the meter is a unit of length and second is the unit of time. In case of force, we have a unit of Newton, that is the kg ms minus 2. Here we can take example of the derived quantities. Like the derived quantities, what are these? We can say about the derived quantities. We have learned that the derived quantities are those whose definitions are based on their physical quantities. We can take example of acceleration. And in case of acceleration, we have unit of meter per second square at the meter per second square. Now we can observe that meter is the unit of length and second is the unit of time. It means that the length, and as we know that the length and times are both base quantities. So we can say that the derived quantities are those whose definitions are based on the other physical quantities. Other physical quantities means based quantities. We can also take example of one more thing, that is force. In case of force, we can say Newton. Newton is the unit of force, and Newton is equal to kg, kilogram meter per second square. And here we can say that the kilogram is the unit of mass, meter is the unit of length, and second is the unit of time. So these are the combination of other physical quantities, mean base quantities. Now we have learned about it, that what is the difference between the physical quantities and their derivations like the derived quantities and base quantities. Base quantities actually are those quantities that are the fundamental quantities, and we have learned that the 7 are the most fundamental physical quantities, and in case of the derived quantities, these are based on the other physical quantities. You can have a glance upon the definition again. After that, we will come to our next point, that is the based unit and the derived unit. Mostly it is asked that what is the difference between the based units and the derived units. So let's learn about that. A base unit is a unit adopted for measurement of a base quantity. It is actually a unit that is used for the measurement of base quantity. Like in case of length, we use the unit of length meter. Meter is the unit for the measurement of the base quantity, that is length. It is a fundamental unit that is defined arbitrarily and not by the combination of other units. The base units of SI systems are the meter, kilogram, second, ampere, Kelvin, mole, and candela. In case of derived units, derived units are the combination of the base units to express the physical quantity. Like the combination will contain the base units in multiplied or divided form. For example, the velocity is the distance traveled per unit time. Means the distance must be in meter or millimeter, kilometer, fine, and per unit time means second, fine. So the unit of velocity is ms minus 1. After that, you can also have a glance upon this is the based units, and the second one is the derived units. You can also have a glance upon their units, upon their equation. And in case of the force, we have learned about that the unit is Newton is the unit of force. This is a special unit name, and its equation include the mass, that is in meter, and acceleration, that is a kg per second square. And in case of frequency, the number of waves passing through a cycle per second. After that, key to the SI definition constants. This is actually, I have only put this over here to tell you about some of the constants, some of the variables that we mostly we don't know about them. Del V is the ground state hypertime transition frequency of the cesium. In case of C is the speed of light in vacuum C, and we have learned about from here the different constants along with their values. H is the Planck constant, E is the elementary charge, Kb is the Boltzmann constant, and N is Avogadro constant, and Kcd the luminance efficacy Kcd of monochromatic radiation of frequency. Now come to the scientific notation. What is a scientific notation? A number is written in scientific notation when a number between 1 and 10 is multiplied by a power of 10 or a power of 10. Scientific notation is a way of expressing numbers that are too big or too small to be conveniently written in decimal form. Here is one example, like we can take example from here 1, 2, 3, 4, 5, 6, 7, 8, 9. We can see that the 6.5 into 10 carries 8. 6.5 point must become after one non-zero digit. And here we can take example that how the exponent, when the exponent goes up, then what should we do? And then when the exponent goes down, then what should we do? Goes down means in minus and goes up means in plus. Move the decimal point until there is one digit to the left of the decimal point. We can take the different examples. Here we can take example of the scientific notation. Any number that is multiplied by the raise of 10 at the power of 10. Here the power like n. Fine. And here n can be on ascending order, like in plus, or on descending order, that is on minus. We can take example of both of them. Like we have example like 65 0 0 0 0 0. I have write up over here 5 zeros. So we will put the decimal point over here after the one non-zero digit, and this is in the plus form. We can take example of firstly on ascending order. So we will go from here 6.5 into 10. We have to write over here like this, and after that we have to just count numbers like from 5. 5 is the one digit over here after the point 1 and 5 zeros. So we can see, write over here 6. In case of like I have 0 0 0 0 0 5 6. Fine. And this is a one non-zero digit. The most first non-zero digit is 6. Or we can also take example. This is actually the example, and here is the point. Here is the decimal, and we see or we observe from here in this form, and we will see that this one is the first non-zero digit. So we'll write over here 5.6 into 10. After that we have to just calculate that how many digits over here, and we have to write over here like minus 6. Fine. So this is actually the scientific notations criteria. After that, let's learn about the conventions for indicating units, like the rules for indicating units. We have different rules over here. Following points should be kept in mind while using units. Like the full name of the unit doesn't begin with the capital letter. Here we can say that the full name of the digit of the unit. Now here you can see the full name of the unit doesn't begin with a capital letter even if named after a scientist, like Newton. Newton is the name of the scientist, but we can't write this name in capital letters, okay? But when we are going to write its unit only, the symbol of the unit, then we have to write it in the capital letter, okay? The symbol of the unit named after a scientist has initial capital letters, such as N for Newton. The prefix that comes after any word, like after any digit, after any numeric value, and the suffix means the starting word. The prefix should be written before the unit without any space. sorry, the prefix is actually prefix means the starting value and the suffix means the ending value. The prefix should be written before the unit without any space. Here it is the prefix 1 and this is the unit. A combination of the base unit is written each with one space apart. There's a Newton meter and we have to write the two units with the space between them. Compound prefix are not allowed. Like compound prefix means means the two type of are the same type of the unit, like the micro or the pico, nano, and so on. So it must be written in a very simplest form. A number such as the 5.0 into 10 to the 4 centimeter can be expressed in the scientific notation. As we have learned about that, we have to write a scientific notations means we have to write any numeric value or anything, any value into a simplest form. This is the greater number 4 and we have to write into a simplest form. So we will divide by 100 like centimeter and it must be converted into the meter. The 100 of difference between them, we will get the 5.0 into 10 to the raise 2. When a multiple of the base unit is raised to a power, then a power applies to whole multiple, not the base unit alone. And this is the example. Like we have 1 into 10 to the raise 3 m square m. Then when we are going to just have a square upon them, then we can say that 10 k means 5 means, like we can example over here. You can say this is a 10 and this is 3. 3 means the kilo and the meters mean meter and this is the meter. When we are going to square upon them, we will write 3 plus 2 5 and meter plus 2 meter square. So it will become 5 and meter square. So this is actually the example of this point. Measurement in the particular work should be recorded immediately in the most convenient unit, the mass of the calorimeter in grams, but before calculation for the result, all measurement must be converted to the appropriate SI base unit. So here I have shown you the difference between the SI base unit, length, mass, time, electric current, temperature, amount of a substance and luminous intensity. These are the kind of the base units, their names and their symbols. And same here, the derived units, the derived quantity, their name, their symbols and their equivalent SI units. This will show about that how they have been derived by the combination of the base units. And this is SI prefix like mega, giga, tera, peta, exa and so on. We have to memorize, we can memorize them like pico, nano, micro, milli, centi, deci, deca, hecto, kilo, mega, giga, tera, peta, exa. After that we will come towards errors and uncertainties. What are errors and what are the uncertainties and what are their reasons? First we have to learn the reasons of errors occurrence. Now come to the reasons of error occurrence. It can be done due to the negligence or the inexperience of a person who is doing experiment without any experience. The faulty apparatus means any fault in apparatus like the vernier caliper or the screw gauge. An inappropriate method or technique, if you are using the different method or inappropriate method, that method is not valid and you are using that to find your precision, to find your accuracy, then you will definitely have some errors. The reasons of uncertainty include the inadequacy, limitation of an instrument, that any instrument having, for example, having the limitation of the 0.0001, and if you are going to more elaborate and you want to just have an experiment that may be beyond to 0.0001, and then you will definitely will have some uncertainty issues. Are the natural variation of the object being measured? Are the natural imperfection of the person's sense? We can say that all physical measurements are uncertain, are imprecise to some extent. It is very difficult to eliminate all the possible errors or uncertainties in a measure. You have to do that alignment, you have to do that measurement once or twice to remove your errors or uncertainties. After that, the type of errors. What are the different type of errors? There are the two different types of errors. One is the random errors and the second one is the systematic errors. Sometimes uncertainties can be considered as errors in measurement. Like the random errors is said to occur when repeated measurements of the quantity give different values under the same condition. Repeating measurements several times and taking average can reduce this error. We can take example of the random errors. That may occur due to the unrepeated or the repeated measurement that shows the values changing every time you measure. If then there are random errors in the experiment. For example, if you used a stopwatch, consider this is a stopwatch. And if you are using the stopwatch for exercise to measure an event, you might measure the 3.55 second. This is the one experiment that you are doing in the first trial. After that, you are continue to measure your distance, that is the 3.25 second. And after that, you are just keep on experimenting and keep on recording and keep on estimating your event or to measure an event. And at the same time, you have you have the same digits like 3.55, 3.25, 3.45 and 3.65, but you are in the range of 3. It means you are going to have an average of these, fine, or wherever after many trials you might end up with an average of 3.35, but you overestimated that the time as much as you underestimated it. Whether or not you overestimate or underestimate on the next trial, however, is totally random. I hope that you understood about the topic of the random errors, that how it can be controlled. After that, come to this point, the repeating measurement several times and taking average can reduce this error. Now come to the second type of the error, that is actually the systematic error. Systematic error is actually refers to an effect that influences all the measurement of a particular quantity equally. It produces a consistent difference in reading. It occurs to some definite rules. It may occur due to the zero errors of an instrument, like the zero error of screw gauge or the vernier caliper, like the poor calibration of the instrument if you are using that instrument poorly, if you don't have any knowledge, don't have any experience how to use that, incorrect marking, and if you are goes on just doing incorrect marking. It can be reduced by comparing the instrument with another which is known to be more accurate. A correction factor can be applied. You can also avoid the systematic errors by having some knowledge, or by having some knowledge about what are the zero errors of that instrument you are going to use, or what are the calibration of that instrument, or how to do the marking of that instrument. I hope you would like this lecture. Our next lecture will be about the significant figures, its rules, precision and accuracy. If you have any question about the lecture that I have given today, you can ask me any question that is any relevant question about this lecture in my comment section. You can ask me over there and I will definitely reply to your questions. I hope you would like this, don't forget to like, share and subscribe. Thank you so much.